Ching, and here's the notes. I'll try and keep them kind of to the left for those who might just watch it in recording later. So nothing gets blacked out, hopefully. Make sure you get all the detail when you copy this diagram down. Note the number of cars. Note these little things. This fancy thing here. Okay. These half hot dog looking things. There's trees in the background. Fox 4, don't do this because that's copyright. So don't copy that down. Oh, finally, Nathan. I mean, Nathan, Matthew. Goodness gracious. Electric energy and power plants. That's the unit. It's a long unit. We will probably, if we come back to face-to-face, we will still be doing it. If we don't come back to face-to-face, I guess we'd still be doing it. Regardless, this is most likely the last unit. Be some kind of built-in time for review and stuff, and we'll see what happens, but this is most likely the last unit. Ada, please tell me when you're done copying this page. The heck, something just, what happened? Something weird just happened on my screen. Just saw your chat, Matthew. Is everything good? Someone left. Might have been Matthew. He might be restarting. Am I on mute right now? I'm just hearing nothing. Sorry, I know your screen just went away. I'll be back in a second. I just want to find, or whatever. I'll leave it. I just don't know if I'm muted. Somebody say something so I know that you can hear me.
You're not muted. We can hear you.
Thank you. And you're probably all thinking, stop talking.
Yeah, I'm trying to concentrate.
I'll stop talking now. Am I recording? Yes. Okay. Oh, crap. Matthew, make it as if on key. Matthew, you having some technical difficulties there?
Yeah, my audio wasn't working and it took forever to reload Classroom.
Everything seems okay now?
Yeah.
All right. Ooh, 431 cases in Winnipeg today. Oops, I said I wasn't going to talk.
I'm done.
Thank you. Matthew, can you tell me when you're done, buddy? Pretty please.
Morris Mai's baking on Saturday, by the way.
Cool beans. Are you guys delivering Saturday or it kind of depends?
Yeah, I think we're delivering. There's like 30 dozen we have to deliver.
Oh. how many
I'm probably gonna get roped into doing that.
dozen can you cook at a time?
Like 5.
Wow. This is a whole family affair, or just is her and a couple of sisters, or what?
Actually, lots of the family is going out to a cabin.
Smart.
I'm staying behind, and Maya is too. So I guess that's us,
You.
Hannah.
Goodness gracious. Where's the cabin?
It's out on like a private lake.
Oh, so it's a secret. Okay.
It's on the border. I don't even know, near Killarney.
Okay. Yeah, I don't even know where that is. There's probably 2 lakes you could say, and I would have a clue. Otherwise, it'd be like, oh, nice. Matthew, you still writing, buddy? I don't know if your audio is working or anything.
I just finished.
All right. So, electrical power, that's energy over time. So it's expressed in watts. But when the numbers are really big, like it says here, it's measured in kilowatt hours for homes and megawatt hours for power plants. Or really anytime the numbers get really big. So 1 kilowatt hour, for example, is 3.6 million joules per second, which is the same as watts. Cool, cool, cool. There's just this and then the assignment. So let me know, please, Ada, when you're done with this page. Thanks, Nathan.
I'm done, by the way.
Thank you. Anybody else still writing? All right. The kind of interesting part here, brownouts. If no more electricity can be generated, more needs to be purchased elsewhere. If that's not an option, areas may experience brownouts. It's kind of a rotating, it's like this part of the city won't get electricity. Now this part of the city won't get electricity. Now this part of the city won't get electricity. Some big cities where it gets really hot, that happens because the air conditioning can't keep up. Air conditioning takes a lot of, or not air conditioning can't keep up, the power supply can't keep up to the air conditioning because there's no practical way to store electricity. So it's kind of almost the electricity that's being used is being sent and has just kind of, for lack of a better word, created more kind of transformed. You can't just store it up the way you store anything physical. So it's almost like the moment it's been transformed, it's used. Something else to say about that, and I forgot. So let's go to this.
What chapter is this?
11.
I'm done if you're waiting for me.
I am. Anybody else? Everybody good? All right, let's go to the tutorials. You should probably have a look. What in the world? How do I change this? All right. Power is energy over time. It's that simple and that complicated. Let's look at the practice questions from page 506. Number 1 says a compact fluorescent light bulb operates with 7 watts of power. P equals 7. Calculate the energy it needs to provide. So E, we don't know. For 24 hours, time equals 24 hours. Remember that everything's in seconds, unless otherwise stated. So there's 60 minutes in an hour, 60 seconds in a minute. I'll figure that out in a second. So let's plug in what we know. P is 7. E, we don't know. Time is 24 times 3,600. I can do that part in my head. So it's 7 times this. And that will be our joules. Where's my calculator? 24 times 3,600. It's 86,400 or 8.6 joules. Sorry, times 10 to the 1, 2, 3, 4, times 10 to the 4 joules. That's
So
not.
you have to multiply that by 7.
Oh my word. Let's not start this again. 86,400 times 7. Yeah, we do. 604,800. That's probably better. So 6.0 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5 joules. Thanks. Makes sense? The only time this would get kind of tricky at all is just converting, or, you know, if you kind of fall asleep in the middle of an equation and think you're done when you haven't even done anything. Okay, assuming that's good. Gonna move on. We'll leave it like that for number 2. Number 2 says, convert your answer in question 1 to kilowatt hours. Okay, so this was our answer. So it's 604800. Remember, kilowatt hours is kind of 1,000 watts per hour. And 1 hour is 60 minutes times 60 seconds. So per 3,600. And so that's the work that you have to do. So it'd be 604,800. You multiply it by 1,000, and then you divide by 3,600. 604,800. You guys hear that in the NPR? It sounds like bird calls or something. Oh, hang on a second. These are watts, kilowatts. We got to divide by 1,000. Sorry. Going from watts to kilowatts. Think of it as meters to kilometers. The number will get smaller. So 604,800. I'm distracted. Can you guys hear that NPR? I don't know what they're doing. Divided by.
No, we can't hear anything, or I can't.
It's like this, whoop, whoop, whoop. And then somebody else is repeating it to somebody else. I'm going to carry my laptop so you can hear it in a second. So I got 0.168, which would be 0.17 kilowatt hours. Divide by 1,000, then divide by 3,600. Does that make sense?
How can you convert joules to kilowatt hours?
It's convert your answer, because yeah, it is in joules. Yeah, kilowatt hours should be in oh no, that's right. Remember we did what unit was this? There was a unit before, wasn't the most recent one, because we've had to skip around. I feel a little bit out of it. Yeah, before waves. Hang on. Six? Oh, chapter 5. Goodness gracious. Yeah, it was chapter 5. The reason that it's in kilowatt hours is because when we're talking about that amount of energy, quite often it's having to do with charges, and so it's charged per hour, and that's kind of the reason for it. I know it seems like you're going from one type of unit to the next. How can I explain this better? So let me just think out loud in front of you for a second. So power equals energy over time. Power is either in watts or joules per second. Energy is in joules. Time is in seconds. So power is joules per second times seconds. When we're multiplying to get that. I don't know how to answer that for you.
Okay, that's fine.
Well, here, you know what? Actually, let me put it this way. So what I'm kind of noodling around here is I'm doing PT equals E. So PT, why is this so crooked? PT equals E. So power times time, which is joules, right? And that's why, and that makes sense. Energy is in joules, but the energy could be kilowatt hours. So it's 1,000. So power is watts. So we change it to 1,000 watts times hours, and time is multiplying power. That's why it's kWh written like this. There's no per. It's like kilowatts times hours. Does that help?
Yeah, that helps a lot.
That makes sense. So
Yeah.
power is in watts, then you make it kilowatts, and then you convert your seconds into hours. So it's kilowatt hours. It's a good question. You floored me for a second. Other questions? It appears the bird calls have stopped. Otherwise, I was going to run over there with my laptop. Now it's just talking.
Am I still going to be marked absent?
Whose voice is that?
Matthew.
I guess I'll change it. Yeah, sorry. When we started, you weren't there yet, but I'll change it. Change it right
All
now.
right, thank you.
Good that you said to remind me. Any other questions from anybody? All right, my friends, you have a lovely weekend and stuff. For what it's worth, I have an appointment soon, so I'm leaving right away. And then there's PD and stuff tomorrow, so it'll be sketchy responses, but if you send me a message over the weekend, like between now and then, I will get back to you, just probably not right away, just so you know. That's all I got.